is the 26th. So these pages will be posted after class with everything we discussed, with your questions and everything else. Let me know if this is clear. And I would like to start with these three special products, not because I'm lazy and I don't want to answer questions about them later. It's just because I would like to put these behind us for good. So the first question is, if anyone remembers what a plus b squared represents, and if I mispronounce your names, please correct me. Don't get upset. My apologies ahead of time. Okay. Okay, let's start with Jordan. Jordan, do you remember how to do this?
Yeah, you'd make two parentheses, a plus b times a plus b, and then you'd use FOIL method to...
Okay, we are not going to use FOIL anymore because we are in calculus. It's not wrong. I'm not disagreeing at all. But we are moving forward. We are going to use the shortcut. We're not going backwards. We're going forward, which means this is the first term, ft if you want, and this is the second term, st, second term. So what does this mean? It means the first term squared plus 2. I have a lot of students asking me, where does the 2 come from? Because there are two terms identical, like terms, and they have to be added up. So times the first term times the second term, first term, second term, and plus the second term squared. So now I would like us to look at an example. Let's say 3x plus 5y squared, everything squared. And I would like you to not FOIL. Will I deduct points if you FOIL on a test? No. But please, let's move forward because this is a very basic topic. So let's say Lindsay. Any questions here? And Lindsay, I would like you to just tell me at least the first term that I have to write. Hello, Lindsay?
Sorry, I was still muted.
That's okay.
The first term would be 3x squared.
Yes, if you want to write it like this. But we should move on from that too and just write 9x squared. It's not wrong. Okay, let's take a look at the second term. Let's say Gabriel.
Wait, that's me?
Yes.
Gabriel?
Yes.
Okay, that's me. Okay.
Gabriel, thank you.
Second term is going to, I'm not too confident, but so it's going to be, it'll be the first term, second term.
So we have to write 2. We should move on from that too. First term, what is the first term?
First term is 3x.
Good. What is the second term?
5y squared.
Very good. And now the second term, let's say, is it Nabitha? Hello?
Nabiha.
Nabitha?
Nabiha.
Nabiha. Thank you. Sorry,
Yes.
my mistake. Okay, what is the last term here?
I got 5y to the 4th, but would you do 625?
But you mean this. But you mean this.
Yeah, that's what I mean, yeah.
Yes, you cannot square just y squared. You have to square 5y squared, correct? Yes, everyone with me? So finally we get 9x squared plus, can anyone give us the second term? Is it Derek?
25y.
So say it again.
I'm sorry. Who are you calling on me?
Derek.
Sure. It's 2 times 3, 15.
Careful. So you are saying 2 times 15.
Sorry?
You're saying 2 times 15, or you're saying 6 times 5? This is,
no.
careful, this is not a distributive law. We're not distributing here. We are multiplying.
So would it not be 6x plus 5y?
There is
squared?
no plus here.
I'm sorry, times.
Good, so let's multiply.
So it's 2 times 3.
Right,
6 times 5.
good, which is?
30.
Yes.
X plus y squared. Or not plus, but y squared.
Excellent, very good. Plus, let's say Gia.
Would it be 25y to the fourth?
Excellent, very good, well done. Okay, so obviously the second one should not need any more explanation, but you will ask questions if you have any, right? So can anyone give us the expanded form of this binomial squared? Binomial squared is a trinomial. Please do not say that that is a squared minus b squared. This is not a binomial, but a trinomial.
A squared minus 2ab plus b squared.
Thank you, 10. Very good. Excellent. So again, do we need another example or we can move on? Do we understand how to follow the pattern? Anyone?
Yes.
Anyone needs an example, please unmute yourselves. Anyone? Okay, in that case, I'm going to go to the very last one. And this is an agreement I like to say forever. So please don't forget this one. And a plus b times a minus b. This is not these two. This is a binomial squared, binomial squared. Please remember it equals a trinomial. But this is the difference of squares. Difference of squares. This answer, difference of squares. Can anyone give us the answer for this? Let's say, is it Kilon?
It's a squared minus b squared.
Great job. Okay. So an example of this would be both binomials are identical except the sign in between. So I'm just picking 4x squared minus, let's say 5y to the third. And of course, 4x squared plus 5y to the third. Any questions? Okay, let's hear from India.
The first one would be 16x squared.
Careful.
X to the fourth. Sorry.
Excellent. And Josh, minus?
Negative 25y to the power of 6.
Excellent. Good. Okay, I think we had enough of this. Anyone? Okay, perfect. So we established those three products, I should say special products. And now I would like to you to take a look at what we call a readiness quiz, because I would like to prepare you for that readiness quiz. And again, if you need more time, I can extend that. Okay, so you may not see this, but it's okay. I'm going to write it for you here. I'm going to pick some questions. I'm sure, I don't know if you can see this. So let's work on number 1. If you'd like to pick any of this, please do so. I will post this document, including our notes. Anyone would like to pick, or I will?
Can we do 1e?
1e, very good. And here it is. It's 2x to negative 3 and y squared, everything to negative 3. How do we start on this? Jordan? And what is
Do you
the idea?
distribute the negative 3?
Say that again.
Do you distribute the negative 3?
Sort of. It's not a distributive law. So let me explain. I understand what you're saying, but let me just emphasize that the distributive law requires product and subtraction or product and addition. This is what we call the distributive law. Here it is an example. Let's say 2x, x minus y. We distribute this monomial to these two terms. This is the distributive law, and we get 2x squared minus 2xy. Now here, the idea is very similar, but we are applying the exponential rules. If you say, remind us of the exponential rules, I will do so. If anyone needs a refresher. Do not be shy. Nobody's picking on anyone.
Could you review, please and thank you?
Okay, so before we answer this question, let's review exponential rules. Okay, here's one. A base raised to power n, or m first, doesn't matter, times a raised to the nth power. These two bases have to be the same. We do not do anything to it. We copy the base and add the exponents. So for example, 2 to the third times 2 to the fourth, we copy the base, add the exponents. When we divide these exponential notations, a to the mth power over a to the nth power, I hope you can see if there is a glitch or something, because I'm not watching the screen all the time. I'm more watching my recording on the right device. So stop me then. Here we subtract always in this order from mn. In other words, let's say 5 to the fourth over 5 to the third. I copy the base, subtract 4 minus 3, not 3 minus 4. 4 minus 3, and I get 1. Another exponential rule is this. When we raise an exponent, an exponential expression to another exponent, here we copy the base and we multiply the exponents. So let's say 5 to the third, everything to the fourth will be, I copy the base but multiply the exponents. These are the basic ones. Some other exponential rules. Let's say a raised to 0 is always 1, except 0 raised to 0. So here, mandatory a, the base cannot be 0. Another very important one is when we raise a base to a negative power. So this is 1 over a to the third power. In general, a to negative n equals 1 over a to the nth power. Now it depends if we have a fraction. Let's say I have 4/3 to negative 2. When I simplify this, I flip the fraction and change the sign on the power. So this becomes 3 over 4 raised to the second power. When I simplify, how do I raise a fraction to the second power or any power? I raise the top to that power. I raise the denominator to that power.
Professor, can you move your paper up a little bit? It's hard to see the bottom of it.
Oops, sorry.
Thank you.
Thank you. Any questions? Any questions? Okay, so now I think we are ready to go back to our question. So it's sort of, but it's not a distributive law. Okay. There are 3 factors here. All 3 factors have to be raised to the same power. Since I don't have enough room, I'm just going to go to the next page. So You can still see, I hope. Okay. So I raise 2 to negative 3. I copy the base. And let's say, Oscar, what will you do next?
In that case, would be